now that we've talked about measurements and units and similar figures, we're going to go through some calculations. And we're specifically going to work on conversions. There we go. We're going to specifically work on conversions, and we're going to use this method called dimensional analysis. We're going to use this method called dimensional analysis because it's a systematic way to plug in conversion factors into a calculation, and a systematic way to do the calculation that is easy to check. It's hard to make mistakes, and it's clear where you do make a mistake. Okay, I'm going to expect that you use dimensional analysis in your homework and on exams when you're supposed to use it, when we're doing conversions. We're going to see that in chemistry, a lot of calculations are conversions. Even when they first don't seem like it, a lot of them are. So when your conversions simply use a conversion factor, we're going to use dimensional analysis to do it. Okay, dimensional analysis simply at each step cancels a unit. Okay, so typically we're going to start with a number that has a certain unit, and as we go through each step of the conversion, if there's more than one, we're going to cancel the unit we have and go to a new unit. And we're going to do that until we get to the unit we want. Okay, so in the metric system, we saw we had this conversion table that allows us to convert between prefixes in the metric system, where the prefixed unit, where in this table it shows how the prefixed unit is related to the base unit. Okay, the prefixed unit, these are the prefixes, these are the values they're worth, and gives us examples over here. For example, if we're dealing with tera, 1 terabyte, like in computers, is equal to 1 times 10 to the 12 bytes. Okay, so this is always how that unit relates to the base unit. So 1 prefix unit is equal to this many base units. Okay, so 1 tera whatever, let's do meter, 1 terameter is equal to 1, what is it, trillion? 1, 2, 3, 12 zeros. 6, 7, 8, 9, 10, 11, 12 meters. Okay, typically we wouldn't write it that way. We would write it as 1 times 10 to the 12th meters. Okay, so the base unit or the prefix unit is equal to that many, that number in there of the base unit. All right, so I plugged that in. I've left the table here, but you can also print off the conversions that I gave you and use those. Okay, a new laptop computer can do approximately 1 billion calculations per second. That means one calculation takes about 1 times 10 to the negative 11 seconds to do a single calculation. Convert this time into picoseconds, right? So this is seconds. I want to go to picosecond. So I'm going seconds to picoseconds, right? Because pico prefix is p. We can see that we're not changing anything. We're still using time, seconds to picoseconds, and we're in the metric system. The only thing we're changing here is the prefix. So we're going to go to our metric system table, which is this, and we can see down here is pico. And pico means 1 time or 10 to the negative 12th. That means 1 picosecond is equal to, remember, 1 of the prefix unit is equal to this number of the base unit. So 1 picosecond is 1 times 10 to the negative 12 seconds. Okay? So a picosecond is a trillionth of a second. It's a very, very short amount of time. But to go from seconds to picoseconds, I'm going to use this conversion. It doesn't matter if it shows picoseconds first and seconds here second. That doesn't matter. It tells me 1 picosecond is equal to 1 times 10 to the negative 12 seconds. That's all I care about. Okay? It takes me from seconds to picoseconds. When I do conversions, I write it out like this. I figure out how I'm going to get from where I am, seconds, to where I need to get picoseconds, and then I find the conversion for it, I write it down, so that when I do the calculation, it's all right there. Okay, when you do the calculation, start with the number that you're given. That's what I want to convert. So 1 times 10 to the negative 11 seconds. Okay, dimensional analysis, I use the train track method. You can use the train track method or the simple fraction method. I'll show you that in a second. But you need to do it this way. Okay, I've got seconds. I need to cancel seconds in my calculation. So that means the seconds have to go down here, right? Because seconds divided by seconds cancel out. And the units I want to get to is picoseconds. So picoseconds goes on top. I go to my conversion. 1 picosecond is equal to 1 times 10 to the negative 12 seconds. The seconds cancel. I have picoseconds left. Okay? If I have the same unit on opposite sides of the fraction, they cancel out. Every step of your conversion, the unit that you currently have should cancel in that next step. And you should get a new unit. I had seconds, it cancels out, now I have picoseconds. Okay? That's the nice thing about dimensional analysis. Okay? This is the train track method. Somebody named it that. Basically, it gives, I write kind of like this track thing. I start with what I've got, and then I put in the conversion. If I want to do this simply with fraction method, I would do 1 times 10 to the negative 11 seconds times, put my fraction here, 1 picosecond is 1 times 10 to the negative 12 seconds. Same thing, seconds cancel because they're on opposite sides of the fraction. Same exact thing, except this uses kind of multiplication signs and fractions, and this simply uses kind of the lines. It's the same freaking calculation. Okay, so anything in the numerator, anything in the top I multiply by, anything in the denominator I divide by. That's a 12. That's a 2. Okay, so multiplying or dividing by 1 does nothing. So I need to do 1 times 10 to the negative 11th divided by 1 times 10 to the negative 12th. So in a different video, I show you how to deal with scientific notation on your calculator. If you don't know how to do that, come to my office hours or contact me and I'll try to show you how to do it. Okay, know how to use your calculator. So 1e11 or 1e negative 11 divided by, because 1 times 10 to the negative 12th is in the new denominator, so I'm dividing by that. 1e negative 12. The answer is 10 picoseconds. So 1 times 10 to the negative 11 seconds is 10 picoseconds. I have one significant figure here. Metric system conversions are exact, so they don't affect significant figures. I start with one significant figure. My answer has one significant figure because that trailing 0 doesn't count. Okay, down here would be the same thing. 1 times 10 to the negative 11 seconds divided by 1 times 10 to the negative 12 seconds. This would give me 10 picoseconds also. Doesn't matter what, if you use the train track or the fraction method, I don't care. You got to do it one way or the other. All right. Let's do another example. The diameter of a red blood cell is about 0.00075 centimeters. Convert this to micrometers. Remember, micro is that weird U, Greek M actually, mu. So we can see that's right here. Okay, So I want to go from centimeters to micrometers. There is no direct conversion between centimeters to micrometers in our table. Okay? Our conversions go from the unit, the prefix unit, to the base unit. So that's what I'm going to have to do. So I'm going to go from centimeters to meters, and then meters to micrometers, because that's what our table does. So I'm going to go centimeters to our base unit meters, and then meters to micrometers. Okay, looking up centimeters. Centi's right here. 1 centimeter is 0.01 meters. So 1 centimeter is 0.01 meters. That's what our table says. The prefix unit is equal to that many of the base unit. And then micrometer, 1 micrometer is 10 to the negative 6 meters. So 1 micrometer, also known as a micrometer, or micron actually, 1 micrometer is equal to 1 times 10 to the negative 6 meters. That's what it says. 1 micro is 10 to the negative 6. So 1 micrometer is 1 times 10 to the negative 6 meters. Okay? So I can go from centimeters to meters using this conversion, and I can go from meters to micrometers using that conversion. Okay? Now we just have to set up our calculation. So 0.00075 centimeters. I'll do this in the fraction method. Doesn't matter. So now I need centimeters canceled. That means centimeters goes down here. The conversion I have with centimeters in it is right here. 1 centimeter is 0.01 meters. That conversion, that's a cm right there. That conversion is right here. 1 centimeter is 0.01 meters. The centimeters cancel. My units are now meters. That means I'm going to use my next conversion to get to micrometers. That means meters has to go down here, right? I've got to have meters cancel. In my conversion, I see that 1 times 10 to the negative 6 meters is 1 micrometer. The meter parts cancel. Notice that my conversion here is exactly here. The meter piece, 1 times 10 to the negative 6 meters, 1 times 10 to the negative 6 meters. 1 micrometer, 1 micrometer. Don't fuck it up. Okay? However it's written here, whatever it came from the conversion table, that's how it needs to go. Don't put 1 meter as 1 times 10 to the negative 6 micrometers. That's wrong. That's not what the conversion says. Okay? Make sure you're doing it right. Alright, now we have to do the calculation. Just do this all at once. Anything in the numerator multiply by, anything in the denominator divide by. Ones you don't got to worry about, because multiplying or dividing by 1 does nothing. So 0.00075 times 0.01 divided by 1 times 10 to the negative 6. I've got 7.5 micrometers. Okay? 2 significant figures here. These are exact, so they don't affect it. 2 significant figures here. So whatever you had in your initial measurement, that's how many significant figures you should have in your answer. Right. So now we also have the English system. Because in America, we use English units sometimes. So we need to deal with that and then see how we convert between English and metric, because the rest of the world uses the metric system. All right, a couple examples of calculations with the English system. So I've got conversions that are distance, volume, weight, time. Okay, so let's do some calculations. So Pikes Peak is a height of 14,115 feet. I want to convert that to miles. Feet and miles are both English units, so we're just going to completely use this table. Okay. So I'm going to go from feet. So I can go from feet to miles directly. And I can see that, remember, miles is MI. 1 mile is equal to 5,280 feet. So using that one conversion, I can convert the height of Pikes Peak in feet to miles. So 14115 feet. So 5,280 feet is 1 mile. So 14,115 divided by 5,280. So we can see the feet units cancel and I have miles left. When I do that calculation, I get 2.67329 miles. I had 5 significant figures to start. My conversion is exact. 1 mile is exactly 5,280 feet, so this does not affect the significant figures. So I started with 5. I should end with 5. 1, 2, 3, 4, 5. 2 is the last significant figure. I'll look after that. 9 is 5 or greater, so I'm going to round the 2 up. So 2.6733 miles. So the top of Pikes Peak is 2.6733 miles above sea level. Second one, a can of Pepsi is 12 fluid ounces. Determine the volume in gallons. Okay, this is a volume, so it's over here. Ounces and gallons, both English units. So we're going to use just this table of English conversions. So we can see that I've got ounces, and 8 ounces is a cup, 2 cups is a pint, 4 pints is a quart, and 4 quarts is a gallon. Ugh. So ounces to cups, cups to pints, PT, pints to quarts, quarts to gallon. Love the English system. Okay, so cups can just be C apparently. So ounces to cups, so 8 ounces is 1 cup, 2 cups is a pint, 2 cups, 1 pint, 2 pints, 1 quart, 4 quarts, 1 gallon. Okay, start with what we've got, 12 ounces. It's fluid ounces, but I'm just put ounces, times. Using the first conversion I got, 8 ounces, right, because we want the ounces to cancel, is 1 cup, ounces cancel, times. We're going cups to pints, so 2 cups, 1 pint, the cups cancel. Pints to quarts, so 2 pints, 1 quart, pints cancel. So you can see at each step we're canceling a unit. And then quarts to gallons, 4 quarts, 1 gallon, quarts cancel, and I'm at the units I want, so now I just have to do the calculation. So it's 12. Basically, we divide by every unit in the every value in the bottom. So I start with 12 divided by 8, divided by 2, divided by 2, divided by 4. So we're dividing by each one because they're each in the numerator. I get 0.09375 gallons. So 12 ounces, 12 fluid ounces is 0.09375 gallons. Two significant figures here. These are all exact. So the leading zeros are not significant. So only the 9 and the 3. After the 3 is a 7, so I'm going to round the 3 up. So 0.094 gallons would be my answer. Awesome English system. All right, now we want to do some conversions between the English system and the metric system. All right, so lung capacity of a student was measured to be 5.2 quarts. Determine this volume in milliliters. All right, so we've got quarts, which is an English unit, and milliliters, which is a metric unit. On our table, we can see that we've got 1 liter is 1.06 quarts. So this table gives us ways to convert from metric to English. That's also on the sheet I give you. All right, so we got 1 liter, and we need to go to quarts. Or no, we've got quarts, 5.2 quarts, and we need to go to milliliters. So we've got quarts, and we know we can get to liters because that's what's on our table here. So 1 liter is 1.06 quarts. Okay? And then if we look at our metric conversion, we can go liters to milliliters because liters is a base unit and milliliters is a prefix unit. And we can see that 1 milliliter is 1 times 10 to the negative 3 liters. That's on our metric conversion, looking at the sheet. Okay, so I go quarts to liters and then liters to milliliters. Starting with what we're given, 5.2 quarts. Converting to liters first, 1.06 quarts. Remember, we want the quarts to go on the bottom to cancel with the quarts there, is 1 liter. And then the next step, we need the liters to cancel. So 1 times 10 to the negative 3 liters is 1 milliliter. Liters cancel. And I've got milliliters as my units. Okay, so dividing by both these because they're both in the denominator, 5.2 divided by 1.06 divided by 1 negative 3 gives me 4,905.66 milliliters. Wow. Didn't realize our lungs were that large. Cool. So 2 significant figures in our initial measurement. So I should have 2, 4, 9. The 0 after the 9 keeps it at 9. So 4, 9. We don't want 49 now. We want 4,900, right? 4,900. We need to put zeros to the decimal. So the student's lung capacity was 4,900 milliliters. Okay. Sample 2. During an autopsy, the length of the deceased intestines was determined to be 1.42 meters in length. Determine the length in inches. Okay. So we've got measurement here. We are in inches. No, we're in meters, and we need to go to inches. So we can see that if we get to centimeters, we can get to inches because 1 inch is 2.54 centimeters. So that means if we get meters to centimeters, which is a metric conversion, we can get to inches. So we need to go meters to centimeters and then to inches. Looking at our English to metric conversion, or vice versa, 1 1 inch is 2.54 centimeters. Okay, that's a centimeter. And meters to centimeters, that's going to be in our metric conversion. And 1 centimeter is 0.01 meters. Or 1 times 10 to the negative 2, whichever one you want to use. Okay, so I'm going to go from meters to centimeters to inches. So let's start with what we're given, 1.42 inches. I'll do just as fractions. 1.42 meters. I keep seeing the in and thinking inches. 1.42 meters. So the meter part has to go in the denominator. And the centimeter part goes on the top. Okay. So that gets me to centimeters. Now I go centimeters to inches. The centimeter part of my conversion goes in the denominator. 2.54 centimeters is 1 inch. So the centimeters cancels, and now my units are inches is what I want. So doing my calculation, 1.42 divide by 0.01 divide by 2.54 because they're both in the denominator. So 55.906 inches. We start with 3 significant figures. These are exact conversions, so we should have 3 significant figures in our answer. 55.9, after the 9 is a 0, so we're going to leave the 9 as a 9. 55.9 inches is equal to 1.42 meters. Okay? One more, and then we're going to give you some practice. So we're going to have mixed units here. We're going to have a unit in the numerator and the denominator. And we're going to convert and show you how to do that. Okay. Usain Bolt holds the record for the 100-meter dash. In 2009, he ran 100 meters in 9.58 seconds. Determine Mr. Bolt's average speed in miles per hour during this run. All right. So let me set this up for you. We have that he ran 100 meters. We'll assume that that's exact. It's not quite, but it's not going to be the thing that limits our precision. 9.58 seconds. So we have meters per second. We have a distance per a time. And we want to convert that to miles per hour. So we need to convert miles to meters and seconds to hours. So I can go seconds to minutes because I know 60 seconds is 1 minute. And I go minutes to hours because I know 60 minutes is 1 hour. Okay, that'll convert my time. Now I need to go miles. I need to go meters, because I'm starting with meters, to miles. If we look at our English to metric conversion, I can go from meters to inches. I can go kilometers to miles, or miles to kilometers. So I go miles to kilometers, which is 1 kilometer is equal to 0.62 miles. And I can go kilometers to meters because that's just a metric conversion. And 1 kilometer is 1,000 meters. All right, so those are the conversions I need. I can go miles to meters and seconds to hours. Okay, let's do time first. So I have seconds in the denominator. So that means the second part of my conversion needs to go in the numerator. 60 seconds is 1 minute. The seconds cancel. Okay? Notice I had to put them in different parts of our fraction, so the second part had to go in the numerator. I have minutes, actually I have meters per minute now. I'm going to use the minute conversion to hours. 60 minutes is 1 hour. The minutes cancel, and now I've got hours in the denominator like I want, because I'm going miles to miles per hour. Okay, now I need to convert the meters. I've got meters to kilometers. Oh, I fucked it up. Okay, let's write this again. So I'm starting with meters, and I need to go to miles. So I can go meters to kilometers. So 1 kilometer is equal to 1,000 meters. And I need to go kilometers to miles. I know that 1 mile, nope, I know that 1 kilometer is equal to 0.62 miles. Okay, so starting with meters, I've got meters, I want to go kilometers, so 1,000 meters is 1 kilometer. Meters cancel. I have kilometers per hour. I need to convert kilometers to miles. 1 kilometer is 0.62 miles. The kilometers have to go in the denominator, so they cancel. So now I've got units of miles per hour. So miles per hour. Do the calculation. Anything in the numerator multiply by, anything in the denominator divide by. So I'm going to start with 100. 100 divided by 9.58 times 60 times 60 divided by 1,000 times 0.62. So I got 23.299. So basically I have 3 significant figures to start. So I'm going to make this 3 significant figures. 23.2. There's a 9 after the 2, so I'm going to round it to 23.3 miles per hour. So on average, in his sprint, he was running over 20 miles per hour. Remember, he's starting at not moving. Right? He's starting at 0 miles per hour. So that means at some point he's well over 30 miles per hour in this 100 meters he ran. That's pretty fast. All right, this one's kind of getting long, so I'm going to pause. You should pause now. We've got a couple pages of practice to do. So let's do this page of practice, and then we'll pause again. So you should pause. Okay, hopefully you've done these 3. We can see the first one is meters to picometers. That's a metric system conversion. I can look that up on the metric system, on our metric conversion. I can see that 1 picometer is equal to 1 times 10 to the negative 12th meters. That's on our conversion. So a picometer is a really small length. So that's all I need. 1.6 times 10 to the negative 10th meters. Do this in fraction. 1 picometer is 1 times 10 to the negative 12 meters. The meters cancel. And the calculation, 1.6 e to the negative 10 divided by 1 e negative 12 gives me 160 picometers. 2 significant figures here. That's exact. So 160 is correct because that 0 isn't significant because there's no decimal. Okay. Convert 5.82 times 10 to the negative 11 micrograms to kilograms. We've got grams as the base unit. So that means it's purely metric. So we're going to go micrograms to grams and then grams to kilograms. So 1 microgram on our table is equal to 1 times 10 to the negative 6 grams. That's from our metric table. And 1 kilogram is equal to 1,000 grams. Okay, just metric system, changing prefixes, so there'll be 2 conversions. Starting with what we have, 5.82 times 10 to the 11th micrograms. Putting it in as fractions, you could do the train track, doesn't matter. 1 microgram is 1 times 10 to the negative 6 grams. Times, so the micrograms cancel. I have grams, so 1,000 grams. The denominator, so the grams cancel, is 1 kilogram. Okay, the units cancel because I put them in the correct place. 5.82 to the 11th times 1e negative 6 divided by 1,000 because the 1,000's in the denominator. 5.82, or no, 582 kilograms. So 5.82 times 10 to the 11th micrograms is equal to 582 kilograms. 3 stimming figures, 3 stimming figures. Last one, 2.6 cups to milliliters, doing volume. Cups is English, milliliters is metric. So let's go to our English to metric conversion. Doing volume, we have a gallon is 3.79 liters, or let's do quarts. 1 liter. So if I can get to quarts, I can get to liters. So 1 liter is 1.06 quarts. So cups, 2 cups is a pint and 2 pints is a quart. So if I'm going from cups to pints, pints PT, pints to quarts. 2 cups is equal to 1 pint, and 2 pints is equal to 1 quart. Okay? And then liters, I need to get to milliliters. That's metric. 1 milliliter is equal to 1 times 10 to the negative 3 liters. That's off the metric conversion. Okay? So in this, I started with the English to metric unit, and then I worked my English unit to the unit I needed to use that English to metric unit, and then I used my metric conversions to get from the metric unit in that English to metric unit conversion to the metric one I want. 2.6 cups. So we have 2 cups, 1 pint. Cups cancel. 2 pints, 1 quart. Pints cancel. Now I go to liters. 1 liter is 1.06 quarts. Quarts cancel. 1 milliliter is 1 times 10 to the negative 3 liters. Liters cancel. And I've got to milliliters. Each step I cancel a unit. So 2.6 divided by 2 divided by 2 divided by 1.06 divided by 1 negative 3, 613.2 milliliters. Okay, 2.6 cups, 2 stimming figures, so 6 and 1, so 610 milliliters. 2.6 cups is 610 milliliters. Right, one more page, 2 more practices. Take a pause, do these. We'll come back. Okay, so hopefully you've done those. Let's check. So we want the number of seconds in a leap year. A leap year is 366 days. Okay, so let's start with days. We need to go days to what? Hours. So we know that one day is equal to 24 hours, right? We're going to go hours to minutes. 60 minutes is equal to 1 hour. We're going to go minutes to seconds. 60 seconds is 1 minute. Okay, starting with what we're given, we have 366 days. So doing train tracks in this case, 1 day is 24 hours. 1 hour is 60 minutes. Oops, let's cancel days, cancel hours. 1 minute is 60 seconds. Minutes cancel, and I have seconds left. Do the calculation. Sorry, I might have been on the screen for a second. 366 times 24 times 60 times 60 gives me 3162240 seconds. Let's put that in scientific notation. So 3.16224. So we had to move the decimal 1, 2, 3, 4, 5, 6, 7. So 3.16224 times 10 to the 7th seconds. So theoretically, I started with 3 significant figures. 1, 2, 3. The number after the last significant figure is a 2, so we're going to round down. So 3.16 times 10 to the 7 seconds. So leap year is, what is that? 32 million seconds. Okay, last one. Convert miles per gallon, which is the fuel efficiency, right? Your car goes 32 miles per gallon, to kilometers per liter. So fuel efficiency in every other country is in kilometers per liter. Here we're doing miles per gallon. So we need to convert two things. We're starting with 32 miles per every 1 gallon. That's what miles per gallon means. So we need to convert miles to kilometers. So we know that 1 kilometer is 0.62 miles, because that's in our conversion tables. And we need to go gallons to liters. So let's see in our conversion table if we have one of those. Oh, we do. Gallon to liter. 1 gallon is equal to 3.79 liters. Oh, so that's not too bad. Okay, so we have miles per gallon. Let's convert our distance first. So we know that 1 kilometer is 0.62 miles. The miles cancel. And we have kilometers, that's what we want. And now we need to convert gallons to liters. Okay, the gallons is in the denominator, so our gallon piece has to go in the numerator. So 1 gallon is 3.79 liters. The gallons cancel. And the units I have left are kilometers per liter. So I get this left. So 32 divided by 0.62, because that's in the denominator, divided by 3.79, because that's in the denominator. 13.618 kilometers per liter. Two significant figures to start. So the 1 and the 3, 6 is greater than 5, so 14 kilometers per liter. So 32 miles per gallon is 14 kilometers per liter. So practice on these. If you're struggling with these, please come and get help. I know it's a little confusing to start. Use dimensional analysis to cancel units, figure out the conversions you need, plug them in. Right? Sorry this was so long.